What's up, what's up, what's up, fifth graders? Here we go. It's time for some math. Let's do this thing. So we are on lesson 94 today, which is page 696. Go ahead, grab out those math books, get opened up to that page. While you're looking for it, I'm going to go ahead and start talking over some of our objectives for our lesson today. So objective number one, our goal for today is to be able to round decimal numbers to the nearest whole number. I mean, that's pretty easy, right? I feel like we've done a little bit of this so far. So, hey, this is going to be just like any other rounding we've ever done. Super duper easy. All right, and the second thing is to be able to estimate the perimeter or the area or the volume of a geometric shape by rounding those decimal numbers to the nearest whole number before we multiply or divide or whatever. So this is going to be a super fast lesson, easy peasy. Wasn't sure if you noticed, I got my special bow tie on for like Resurrection Thursday, even though I know it's not till Sunday, but I figured it is our last day together before Easter, so I want to look my best. All right, sweet. Now, page 696, let's check it out. Right there down at the bottom, new concepts. Let's go. It says, in previous problem sets, we've answered questions such as the following. Is $7.56 closer to 7 or $8? So we've done that before. Now, if we look at $7.56, give a marker out here. So we got $7.56. All we got to do is look right next to the decimal. So we look just to the right of the decimal. If that numbers are 5 or more, you round up. That's it. That's the whole lesson. Pretty easy, right? So we're going to round this guy up to 8. It's that easy, right? You guys with me? I hope you're with me. You stay with me. All right. Cool. Let's look at the next page here, 697. Let's see. Let's go to example 1, because basically we already did all the rest of that. So example 1, check out example 1 with me. So example 1 says round 7.6 to the nearest whole number. Okay, y'all, right here. All right, is that more than 5? Mm-hmm. So if it's more than 5, then we got to round it up. So we're going to round that one up to 8. Right? You guys are like, Mr. Poole, why are you even teaching us? This is like so easy. I know. This is like, I feel like one of the easiest lessons we've had all year. So let's keep going. Example number 2. Little bit more difficult, but not really. It says estimate the product of 8.78 and 6.12. Now, it's talking about products, so what do they want us to do? Someone say it. Say it nice and loud so your mom knows you're paying attention to the video. Cassidy, what do you think? Say it nice and loud. So, they want us to find the product. What was that again? Yeah, there you go. We got to multiply, but we got to estimate first. So let's look at these spots right here. We're going to look right next to the decimal. Now, is this bigger than 5? Mm-hmm. So that means we got to round it up. So we're going to round this one up to 9. Then let's look right here next to the decimal. Is that bigger than 5? Nuh-uh. So that means we're going to round it down. So we take it down to 6. We don't take it down to 5. We don't want to go down that far. Don't take it to 5. Don't you do it. All right, so we're going to take it to 6. So we're going to round down to 6. Now, 9 times 6, that's pretty easy, right? Someone yell it out. Mm-hmm, I heard you. 54. Nice. See how easy that is? All we're doing, look at the spot. Here's our decimal. I'll make it really big so we can see it. Really big decimal. Look over here to the right. If that number's 5, 6, 7, 8, 9, go up. If it's 4, 3, 2, 1, go down. Easy peasy, right? Sweet. Turn the page. We're already on to example number 3, y'all. You guys are just that smart. All right. Example number 3 is probably the toughest one we've had so far. Let's see. We'll put it up here. I think it'll fit. Example number 3. So we got a shape that looks like this. See if I can draw it. Ooh, that's ugly. We got our dots and our dots. Let's see. It tells us it's 6 meters tall. It tells us it's 4.8 meters at the base. And it tells us that this side is 7 7.24 meters, or 7.2. Sorry, I just want to add a 4 in there, make it more exciting, you know? All right, now remember, if this was a regular rectangle, we would just go, the area would just be the length times the width, right? Right? Isn't that how we do it? But since this is like a parallelogram, it has been tilted over a little bit, we can't just go length times width. We have to go something else. Who thinks they know? All right, if you think you know, go ahead and yell it out. What's this bottom part called? That's the base. So we got to go base times, now are we going to go base times this 7.2, or are we going to go base times the height? Right when I said height, I know some of y'all were like, it's the height, Mr. Poole. Absolutely. So we got to go base times height, and that's it. That will give us our area. So let's read this problem and see what it wants. It says Lorenzo estimated the area of this parallelogram to be 15 meters squared. Did Lorenzo make a reasonable estimate? So let's check it out. My base is 4.8. Ooh, 0.8. Are we going to round that up or down? Is 8 bigger than 5? So we're going to go up here. So my base is going to be 5 times, and then what was our height? We didn't even have to round it, right? It's already just 6. All right, cool. So we're going to go 5 times 6. Now, that's easy peasy, going by 5s. 5, 10, 15, 20, 25, 30. 5 times 6 is 30, right? So we got 30 meters squared. If we work it out, that's what it gives us, right? Or about, because remember we estimated. Now, 30 meters squared, is that anywhere near 15 meters squared? No, so Lorenzo made a bad estimate. Yeah, so we would just say, yeah, he did it wrong. Okay, now, example 4. I'm going to do a quick erase of my board here and hopefully not drop everything. All right, let's see. All right. It's not quite as easy when I got to do it this way versus just tagging the little button that says erase, right? You know, I do miss my board at school. Not as much as I miss you guys, but I do miss my board at school. Having all that stuff digital is pretty sweet, huh? It's quite a bit different. All right, here we go. Now, we got a stop sign here for example number 4. Let's see, example 4. So we got a stop sign. So it looks kind of like this, and like this, and then we do a little connect the dots. Doom, doom, doom. Stop. All right, cool. Now it tells us that one side is 31.75 centimeters. All right, that's not too bad, right? They want us to find what the perimeter, a reasonable estimate of the perimeter would be. So let's look right here next to that decimal. We got a 7, right? So we got to bump that puppy up. So instead of 31.75, we're going to take it to 30. There you go, 32. So we got 32 centimeters. Now count the sides with me. We got 1, 2, 3, 4, 5, 6, 7, 8. So if I'm trying to find the perimeter, what am I going to do here? Yeah, I heard you say it. We got to multiply times those 8 sides. So 8 times 2, 16, carry the 1. 8 times 3, 24, plus 1 is 25. And then we had centimeters. Now, is it just centimeters, or is it squared, or is it cubed? What do you guys think? Yeah, it's this right here. Boom, just centimeters. We're not putting any exponents because we're just talking about the distance going all the way around the outside. We're not talking about any of the area on the inside. All right, so, wow, we're already at example 5, and we're going to be cranking through this lesson practice here in a second. So, example 5, we'll jump over here. Example 5. Now, we got that, looks like a little storage container. Let's see if I can draw it to the best of my abilities. Okay, so down here we got 2.84 meters. And then over here we got 3.04 meters. And then over here we got 2.69 meters. And now it's asking us what's the volume of this shape. And remember, with volume is length times width times the height. We got to multiply all these together, but there's a step we got to do first. Since we're talking about estimating decimal numbers, the whole lesson was on estimating decimal numbers, we got to estimate first. So let's look here next to that decimal. It's an 8. That's bigger than a 5. We got to up that score. So we're going to up that one to a 3. And then 3.04. We got a 0 right there. 0 is definitely not as big as 5. So we got to pull it down to a flat 3. So now we got 3 meters. Now we got 2.69. Check out that 6 next to the decimal. That's bigger than a 5. You got to up that thing up there. So we're going to take this one up to 3 meters. So we've got 3 meters times 3 meters times 3 meters. Now, if we have 3 cubed, or 3 times 3 times 3, that equals a certain number. Remember, 3 times 3 is 9, and then 9 times 3 is going to be, yep, you said it, 27. Now, we can't forget to label. Now, how many times did we see the little m? Let's count them. 1, 2, 3. So if we got 3 little m's, that means we got to put 3 as our exponent there with our answer. So the volume would be about 27 meters cubed for that shape right there. Now, lesson practice. All right, A, check out A. A, we have $6.24. Look next to the decimal. Is it bigger than a 5? So are we going to go up or down? Down, exactly. So we're going to take this one down to $6 even. Is that easy, guys? Seriously, you guys are like, Mr. Poole, this is so easy. Why are we even doing this? Yeah, I know, right? But we got to. So I'm going to do a couple more that I think are a little difficult for us. Let's try C. So C, we have $118.59. Sweet, look next to the decimal. We got a 5. 5 or more up the score, right? Sweet, take it up. So that one's going up to $119 flat. Now, let's jump down to just rounding regular decimal numbers. Let's do G, as in George. So G as in George, here we go. We got 96.41. Let's look there next to the decimal. Is it 5 or more? 4 or less, we got to let that thing rest. So let's let it rest back down to 96. Remember, we don't go all the way to 95. We're just going back down to the whole number that we have out front. 96. All right, let's see. All right, let's do M as in Mary. All right, here we go. M. It says the illustration shows the dimensions of a small gift box. Estimate the volume of the box. Remember, volume is this guy right here. So we're going to go length times width times height after we've estimated the picture. So we got this, and it's kind of a long box. So it goes this way. Okay, so across the front we got 9.8 centimeters. Down the side we got 6.2 centimeters. And then height-wise we only got 1.9 centimeters. All right, let's look at the numbers in the tens places, and from there it's going to be easy as all get out. So let's go. 9.8, 8 tenths, 5 or more up the score. That's right, we're taking it up to 10 centimeters. Now, 6.2, 0.2 is 2 more than 5. No, it's not. If you have problems with that one, call me, like text me, something like get on the computer, because we should know that 2 is less than 5, right? Awesome. So we're going to take this guy down. It's going to go just to 6 centimeters. Now 1.9, check out 1.9 right here. 0.9 is definitely bigger than 5. So we're going to jump that thing up to 2. Now we plug it into our equation up here, length times width times height. So we got 10 times 6 times 2. And then each one of these was centimeters. Forgot to write it in there, but we'll put it in there anyways. Now, 10 times 6. Super duper easy, right? That's just 60. Exactly. 1 times 6 is 6. Drop the 0. 60. Now, 60 times 2 is going to be 120. So you go 2 times 6 is 12. Drop the 0. Boom. 120. Now, we are talking about centimeters, so we got to have our centimeters on there. Now, with the centimeters, how many times did we see it? 1, 2, 3. So that tells us we're going to put a little 3 as our exponent. There it goes. So the volume of that shape is about 120 centimeters cubed. Sweet. We're going to do n, and then we're going to call it a day, or we'll go over a couple of those math questions for you for your homework. Oh man, now I got to erase some stuff again. Let's see. We'll just go for it. Let's get wild. Alright, I hope you guys are getting some like fun stuff in at home, like watching movies with your families at night because you already got your homework done, you don't have to do any homework, and you're like reading books and you know, maybe exercising. Like I'm in my garage right now, I got my weights right here. You know, see if I can kick the plates, you know, like hopefully you're doing some fun stuff at home. I know, you know, you guys are probably bored to death at home right now, but hopefully there's some fun stuff going on. All right, let's check out N as in Nancy. So here we go. We got a funky shape. Looks like this. And it tells us that we got our height in here. Whoops, that should be a box. And let's see, it is 1.9 centimeters going up there. This side over here is 2.3 centimeters, but notice it is not straight up, it's angled. And then we got our base, which is 3.1 centimeters. Now remember, with the parallelogram, we just had an example like this, you guys. So with this parallelogram, remember, is it width times the length? No, it's what? Say it. Base times height. So my base, we got to round this base. That's a 1. So that means we're going to drop that thing down. So it's going to be 3 centimeters. Now our height is 1.9 centimeters, so we're going to jump that thing up because 0.9 is really close to 2. So our base is 3, our height is 2, and let's multiply. So that's going to be 6 centimeters. How many times do we see our little centimeters? We see it 2 times, so that's where we're going to get our exponent. There's our little 2 right there. Sweet. Go ahead and open up to the homework. Go ahead and grab your math sheet so we can go over a couple of these answers, and we'll go over a few here in a second. All right, friends, I went ahead and wrote out some of these questions without you having to watch me do it. So let's check this out. Just want to give you a quick reminder on number 3 on this lesson. It's the area of a triangle. So remember, it's base times your height divided by 2. Don't forget to divide by 2 because remember that triangle is only half of a parallelogram. So if I had a whole parallelogram right here, the triangle is only half. So instead of base times height for the parallelogram, we got to divide it in 2 because here's 1, here's 2. Got to divide by 2, y'all. All right, check out 7. I know we haven't gone over these in a while, and I just want to make sure you're keeping it fresh in your mind. Now, it gave us these 2 fractions, and it said we want to find a common denominator of 12. And then let's see what they want us to do with this one. They want us to subtract the smaller one from the bigger one. So let's do it. Now remember, how did 6 become 12 here? What did we have to do? We had to multiply, didn't we? We multiplied by 2. So if you do it on the bottom, you got to do it on the top. Here we go, times 2. So 5 times 2, that gives us our 10. Now, down here we got to do the same trick. Now, 4 became 12 by how? What do we have to multiply by? 3. So, you could work that 3 in there and go 3 times 3. What's that equal? 9. Sweet. Now we subtract these 2. 10 minus 9 equals 1. And then the denominator does not change. It stays at 12. Cool. 1/12. It's that easy, guys. Number 11, I want to give you a quick hint, real quick. So 10 cubed is not going to be 10 times 3. Nuh-uh. It means 10 times 10 times 10. And then once you get that number, then you're going to subtract 10 times 10 over here. 10 squared. Now, it's not 20 because that would just be multiplying your base times your root, and that is no good on our exponent there. So, awesome. Let's jump to number 18. 18 is a bunch of the problems that we just did today. So I just gave you this little tip. If you got a 5 in the tens place or higher, 5, 6, 7, 8, 9, take that thing up. If you have a 4, 3, 2, 1, 0 in that spot, then you're going to drop that number down. And remember, you only drop it to the base number that's out there in the front. You don't change that front number, you just drop it down, all right? And then, 22. Just want to do another one of these, make sure we're cranking through these ones okay. Remember, when we're dividing fractions, that fraction just drops straight down, the first one. We're going to change our symbol to be multiplication. Then remember, when I draw that little funky whoopsie-doo going on right there, we're using the reciprocal of this second fraction. So instead of 3 over 4, it becomes 4 over 3. Nice. All right, so when we multiply, we get 2 times 4. All right, that's pretty easy, right, guys? Yeah, that's 8. And then we got 3 times 3, and that's 9. Awesome, so we got 8 ninths. All right, I'm going to write up a couple more of these here in a second, and we can crank it out. All right, here we go. Last couple questions. I was going to help you guys out with your math. Number 26. So remember, A, it's asking for the area of this entire shape. So, volume. Volume, there you go. Volume is base times height times width. So, you're just going to take your base times your width times your height. Either way you multiply, you're still going to get the same answer. But don't forget to label it correctly, because how many times do we see centimeter? That's right, 3 times, so we got to cube that thing. Now, B is asking how many faces are on this shape. Don't forget the top, don't forget the bottom, or you'll get messed up a little bit. Now, the edges. C is asking how many edges are in this shape. An edge is every line that you see. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's a bunch. You're going to have to go through and count those. Now, on 29, they want us to graph this information. I already set the graph up for you guys. If you need to take a little time to copy it down, hit pause. So, time across the bottom, distance up the side. And we're doing a line graph, not a bar graph. So that means we're going to put dots on here wherever they belong, and then we're going to start here at 0. We're going to connect the dots across this table right quick. So I think at 10 minutes it said something like, well, at 0 minutes they were at 0 miles. Shocker, right? How could they go anywhere? At 10 minutes they had already traveled 7 miles, so we're going to be about right in there. And then 20 minutes it goes up to 14, so then we're going to be like about right there. And I'll let you put what 30 would be, and then you could draw the line for that thing. Now, B is a little trickier, because B asks us about how long do you think it will take the pigeon to complete the race. The race is 100 miles. So the race is trying to get to 100 miles. Now, how far, if you look at the table, how far have they traveled in 30 minutes? I think we end up with like 22 miles or something like that. So if we double that and make it an hour, 22 times 2 is going to be how many miles? 44 miles, right? So that's at 1 hour long is 44 miles. Now, at 2 hours, so let's double it again, that's going to be about 88 miles. So that's for 2 hours. Now, how much more time do you think it's going to take for them to crank out that last 12 miles? Okay, how long did it take them to fly 12 miles? Okay, so we could come up with a pretty good estimate of how long that's going to be. All right, cool. All right, I hope you guys have a great Easter weekend. And let's see, when we come back, you guys get Monday off also. So you get Friday and a Monday. 4-day weekend, y'all. You don't have to look at my face for 4 days. I know, it's awesome. You're super stoked. So when we come back on that Tuesday, we're going to do lesson 95. And then on Wednesday, we're going to have a math test in the Google Classroom. So I'll have a video for that Wednesday kind of explaining, opening up the document and jumping in there and trying to get that thing done. All right. Yeah. Have a blessed Easter, and I'll talk to you later.